Okay, guys. Today we are going to be looking at polynomials. Our goal for today is to classify, add, subtract polynomials. So before we explain what a polynomial is, we're going to talk a little bit about markers. Now, your teacher uses a lot of markers, and they are all markers no matter what color they are. So if I asked you how many markers are in this picture, what would you say? There are 8 markers in this picture. What would your answer be if I asked how many green markers are in this picture? Obviously, there's only one green marker. So why would it be unreasonable to say there are 8 green markers? They're all markers, but they're not 8 green markers. Variables are just like markers. How many variables do you see? So we see 1, 2, 3, 4, 5 x's, but this x has a squared on it. This x has an x to the third. This one has an x to the fourth. And this one has an x to the fifth. Now, just in case you don't remember, if the exponent is not there, there's an understood 1. So this x is an x to the first power. Now, how many x squared variables do you see? There's only one x squared. And we could write that as 1 x squared, or we could let that x squared have an understood 1. Now, just like markers, it's unreasonable to claim that all variables are the same. X is different from x to the third, just like a green marker is different from a red marker. There are all types of variables, but they must be counted differently. Now, I have some crayons here. 5 blue, 4 red, and 2 green. So, which of the following would be our best description of these crayons? 5 blue plus 4 red plus 2 green, or would we just say 11 crayons? Obviously, this is the best description because that gives us a description of how many and the color, and not just the fact that we have 11 crayons. We can do the same thing with variables. How many of each type of variable do you see? So again, this x with no exponent is an understood 1 for the exponent. So we have 1, 2, 3 of those. So we have 3 x's. For our x squareds, we have 1, 2, 3 x squareds. So I'm going to write that as 3x squared. Then we've got x to the third, I only have 2x to the third, so that'll be 2x to the third. We've got 2 x's to the fourth, so and finally we have 1x to the fifth, so we'll say that's an understood 1x to the fifth power. So if I wanted to write an expression describing how many of each that we see, I could write that using addition, because what I have here is 3x plus 3x squared plus 2x to the third plus 2x to the fourth plus x to the fifth. So why can we not add those numbers together? For the same reason we can't add 5 blue markers or 5 blue crayons and 4 red crayons and 2 green crayons. It's unreasonable to say 11 variables for the same reason it's unreasonable to say 11 crayons. They're not the same kind. So now, on page 357 in your Springboard textbook, we have the definition for the standard form of a polynomial. Standard form of a polynomial is a polynomial whose terms are written in descending order. Now, the word descending means going down. If you descend a stairway, you're going down the stairs. So descending order of degree means the x powers, the exponents, the powers on x are going down. The leading coefficient is the coefficient of the polynomial's leading term when the polynomial is written in standard form. So in this case, in this polynomial, 7x to the fifth plus 2x squared minus 3 In this polynomial, 7x to the fifth plus 2x squared minus 3, the fifth power is the highest one that we have here. So the 7, the coefficient on that highest power, is what we call the leading coefficient. The highest power is the degree of the polynomial, and each one of these pieces is what we call a term. So this polynomial has 1 term, 2 terms, 3 terms. This term with no variable is what we call the constant term. Now, a polynomial can be classified by the number of terms it has when it's in simplest form. A monomial is a polynomial that only has 1 term. So examples of that would be 8 or negative 2x or 3x squared. Notice there are no plus signs or minus signs in a monomial. A binomial, that's like the word bicycle that has 2 tires. A binomial has 2 terms. It's like 3x plus 2 or 4x squared minus 7x. So notice here we have a plus sign here that separates our 2 terms, and we have a minus sign here that separates our 2 terms. A trinomial is a polynomial that has 3 terms. So an example of that is negative x squared plus 3x plus 9. Notice we have 1 minus sign here and 1 plus sign here. That separates our 3 terms. Anything that has more than 3 terms, we just call a polynomial. It doesn't get a special name. But we also call all of these things polynomials. These are just more specific names for them. So now we're going to look at the chart on page 358 in your textbook. So for this first polynomial, we have 2 terms separated by 1 minus sign. So this has 2 terms. So what do we call this? This is a binomial. Its leading coefficient is 3. The constant term, there is none. And the degree is 2 because that's the highest power that we have there. For the next one, we have 3 terms. 1, 2, 3 terms. So we call that a trinomial. The leading coefficient is the one on the highest power. The leading coefficient is the one on the highest power, so in this case, it's negative 2. The constant term is the one without a variable, which is 6. And the degree is the highest power that we have on any term, so in this case, it's 2. For the third one, we clearly only have 1 term, so we call that a monomial. The leading coefficient is the only coefficient that we've got, which is 15. There is no constant term, and the degree is 2. The only power is the highest power. I'm going to let you guys try these 2 on your own. Let's look at this one. On this one, we have 1, 2, 3, 4 terms. So this one doesn't get a special name. We just call this one a polynomial. The leading coefficient is this decimal number that's attached to the highest power. So the leading coefficient is 0.23. The constant term is 0.0218. And the degree is 3. I'm also going to leave this last one for you guys to do on your own. Right, so now let's look at page 360. I'll do a couple of examples with you. On page 360, we are adding these 2 polynomials. For part A, we've got x minus 2 plus 2x plus 5. So here, the first thing we're going to do is pick out the like terms. So I see that x and 2x are like because they both have a power of 1. So when I combine this understood 1x with this 2x, that leaves me 3x. Now for the second piece, we have the 2 constant terms. So we'll have negative 2 plus 5. Negative 2 plus 5 gives us positive 3. We're going to do the same thing. We're going to pick out the terms that are like and combine those together. So we'll start here. We have 2y squared plus 3y plus 6 plus 3y squared minus 4. The first thing I notice is that my highest powers are y squareds. So I'm going to take those 2 together and combine those first, which gives me 5y squared. Then I have a 3y. There's nothing like 3y, so I'm just going to bring it down into my answer. And finally, we'll have these two constant terms. 6 plus negative 4 leaves me a positive 2. Now, I'm going to let you guys do C and D on page 360. On page 364. This example asks us to subtract the polynomial 2x to the third plus x squared plus x plus 10 minus 5x squared minus 4x plus 6 horizontally and vertically, and then write the answer in standard form. So we'll do it both ways. Horizontally, it looks just like this. So I'm going to write it out. 2x to the third plus 8x squared plus x plus 10 minus 5x squared minus 4x plus 6. And we're going to match up the like terms just like we did with addition. But before we can do that, I have to take this minus sign and change it to a plus. But when I do that, I have to change every sign after that. So the positive 5 will become a negative 5. The minus 4x will become a plus 4x. And the plus 6 becomes a minus 6. So now it's just like the addition we just did. I'll pick out the like terms. We have 2x to the third. There's nothing like that, so I'm just going to bring down 2x to the third. Then I have 8x squared plus my now negative 5x squared. That's going to leave me plus 3x squared. Then we've got plus x, positive x, plus 4x. Leaves me with 5x. And finally, my constant terms. I've got 10 plus negative 6 leaves me a positive 4. So that is the method for doing this subtraction horizontally. Now we'll do the same problem, but we'll complete the subtraction vertically. So when I do the subtraction vertically, I write the first polynomial on the top, and then I write the second polynomial on the bottom. But what I'm going to do here is make sure I line up my powers that are alike. So I'll write the 5x squared under the 8x squared, the minus 4x under the x, and the plus 6 under the 10. And I'm going to do the same thing here. I'm going to change all of my signs. So I'm going to change the minus to a plus. I'll change the positive 5x squared to a negative 5x squared. This will become a plus sign, and this will become a minus sign. So now I can just combine the like terms. They're lined up right on top of each other. So the 2x to the third is just going to fall down. 8x squared minus 5x squared leaves me a 3x squared. X plus 4x leaves a 5x, and 10 minus 6 leaves a positive 4. So you can see we got the same answer that we got when we did the subtraction horizontally. You choose your preferred method. Okay, so now let's do a couple more together. This is on page 365 in your Springboard books. So notice here we have one polynomial minus another polynomial. I'm going to do just what I did before. I'm going to change this minus sign to a plus sign. So then this x becomes a negative x, and this 7 becomes a minus 7. So when I combine the like terms, I have 5x plus negative x, which leaves me 4x. And then I've got negative 5 minus 7, which leaves me a negative 12. Now for part B, again, I'm going to do the same thing with the minus sign. So I'm going to change the minus to a plus, and then I'm going to change every sign after that. So this negative becomes a positive, this minus becomes a plus, and this minus becomes a plus. I'll combine the 2x squared and the 5x squared to get a 7x squared. Then we have 3x plus 2x, leaves us a plus 5x. And finally, we've got 2 plus 9, which leaves us a constant term of 11. And now you guys can try parts C and D on page 365. Now, before we finish for today, I want to warn you guys, sometimes these subtraction questions can be worded in a little bit tricky way. Don't let it trick you, don't let it stump you. The way that things can be worded, instead of just saying, what is this polynomial minus this one, you might be asked in question form, what is x squared plus 3x minus 2 subtracted from 3x squared minus 2x? This wording is a little strange. This isn't telling you to take x squared plus 3x minus 2 minus 3x squared minus 2x. This is actually asking you to take the second one minus the first one. It's because of that word, that phrase, subtracted from. That means it's this one taken from this one, which means this one minus this one. So we would perform this subtraction the same way. You're still going to change this minus to a plus, and then change everything after that. So then this would leave you 3x squared minus x squared, which is 2x squared. Then you would have a negative 2x minus 3x, leaves you a minus 5x. And finally, there is no term like the plus 2, so it's just going to come down in your answer. If you perform the subtraction in this order, you will not get the same answer. So be careful with that.